You need to hold each of those people have, like, where the school counselor or maybe some officers and they just have like a partnership with a hotel. To get the like, somehow get.
All right, hope you guys had a nice break. Let me highlight a few things from the calendar. So we started pages 1 through 3. So we'll just continue working through as much as we can today. Whatever we don't finish will be your homework, and it'll count towards. And so tomorrow you'll show me pages 1 through 6. That'll be worth 5 points. And then packets 1 and 2. You guys haven't gone to packet 2 yet. But packets 1 and 2 will go towards your test grade. It'll be worth 50 points for all the homework that we're going to do between packets 1 and 2. And our test will be next Thursday. It'll just be 2 free response questions. One will be a Taylor series problem, and the second one will be a particle motion problem. Okay. Tomorrow we'll walk through the parametric particle motion problems that you can expect to see. It's in your packet, but we'll spend time doing that tomorrow. And then Monday we'll continue to practice. So I think we do get through a good chunk of your homework problems in class, working together on them. So you shouldn't have a ton to do at home, but we do want to make sure that we get our homework done on time, so that we can maximize those homework points that's going to go towards your assessment grade. All right, so you will get to use your calculator on the test rather. Any questions leading up to next week? Okay. And then after that, we're just going to, my second packet will just be review, kind of like an overview from first semester and from this semester. I think I'm going to focus mainly on topics other than convergence and Taylor series. I don't think we need to, we just took a test on it, or take a quiz and a test on it, 2 tests on it rather. I'm going to hold off on that and just focus on the other topics. And then maybe we'll circle back to Taylor series after spring break if we need to. All right, so I left off at number 3. So let's just continue working through. And as you guys, I'm just going to let you guys work through, and I'll work through it, the problems as well. And I'll highlight some things as we go to it. Sure. Hours. Yeah, I can pull that up real quick just so you can see it. So, AP exam, you start with multiple choice, 30 questions, 60 minutes, no calculator. And then second part, 15 questions, 45 minutes with calculator. And then you'll have a break. Then two FRQs, 30 minutes with calculator. Then you'll put your calculator away and you'll have the next hour to work on the next four problems, 3 through 6.
How much time do you think the effort like this?
Yeah, FRQ, about 15 minutes per problem. 15, yeah. But on our quizzes, you're gonna have a lot more time. But yeah, we're eventually gonna have to get to the point where about 15 minutes per problem on average. Okay, let me talk through parts B and C for number 3. Part A, we're just building our first 4 terms, and we're just expanding it. We're finding each of the derivatives, putting it into the proper coefficient terms, and then cleaning it up and building the general term. Part B, we have to see that connection between natural log and 1 over x minus 1, and the relationship is that they're derivatives and integrals of each other. This function represents 1 over x minus 1. So to get from 1 over x minus 1 to natural log of x minus 1, there's going to be a antiderivative relationship. So if I find the antiderivative of this, then that will represent the natural log of x minus 1. Are we good up to that point? So we know we have to go through power rule for each of these terms. So we go through a power rule for each of the terms. We can also do power rule for our general term as well. Just do x minus 2 to the n plus 1 over n plus 1. However, whenever we do an integral, there's always going to be a plus c that shows up. And the way we can solve that plus c, we know that all this represents natural log of x minus 1. Right? And if I plug in x equals 2, I can plug 2 in for x on both sides, and I can solve for c. So natural log of 2 minus 1 is 0. So, and then 2 is just going to wipe out each of these terms here, because 2 minus 2 is all going to be 0. So I'm left with 2 plus 0 plus 0 plus 0 plus c. So this side is 0. So 0 is equal to 2 plus c. So therefore, c equals negative 2. So if I plug c in with negative 2, then really x minus 2 can kind of be thought of as my first term. And then it kind of jumps, and then it kind of goes from there. X minus 2 squared is over 2 is the next term. X minus 2 cubed over 3, x minus 2 to the 4. So we can kind of merge that together and think of that as the first term. So I have my first 4 terms plus my general term. That's part B.
How do you find the general term for 1 over 1 minus x minus 1?
Oh, I built it at this stage here. So this, at the very part A, is 1 over x minus 1, right? So if I look at each of these terms here, it's just x minus 2 to the nth power with an alternator in front. And then if I can build the general term at this stage, then the general term by part B will be a lot easier. You just add that n plus 1. Don't have to build from scratch. Now, part C says use the series in part B to compute a number, basically a partial sum, approximation, that differs from the actual value by less than 0.05. So we know that this is a converging alternating series. So really, if we can find the term that is less than 0.05, then we know that term is the first unused term, and we just have to backtrack and add the first couple of terms leading up to that to produce the partial sum that we want, right? So we want to find the first term in the sequence that is less than 0.05. So if I want to do natural log of 3 halves, and we want to use this natural log of x minus 1, then we have to kind of adjust it, right? Natural log of 3 halves is really natural log of 5 halves minus 1. And if we can write it in this form, then we know it's 5 halves that gets inserted in for all the x's. So the first term will be 5 halves minus 2, which is 1 half. The second term will be 5 halves minus 2 squared over 2, which is 1/8. And the third term is 5 halves minus 2 cubed over 3, which is 1/24. Now, 1/8 is greater than 0.05, so we keep going. Third term, 1 over 24, that is less than 0.05 because 1 over 24 is less than 1/20th, which means that we want an error to be 1 over 24, which means that we want to do the partial sum S of two. Right? We know that the partial sum S of two will produce an error that will meet the criteria that we want because the first unused term is less than 0.05. So my first term is 1/2, my second term is 1/8, my partial sum S of two is 0.375. So we know that this is an approximation. This approximation meets the criteria of being less than the actual value of natural log of 3/2, off by no more than 0.05. Okay, moving on to number 4. Any questions with 4?
By pricey, I say that natural log of 0 doesn't exist. Average.
Well, this is p-value, not n-value.
Oh.
Yeah. What do you what?
Before, like, 4
Oh, why is it changed to 4x? No, what you like talked about? Oh, I was just reducing along the way, canceling out. But you can wait till later, but eventually they will cancel out.
So. I think yeah, like.
Let me see. So yeah, let me go back to part B, but part C, the idea is that, I mean, for part B, we're gonna see that, this series is gonna diverge, right?
Yeah.
So the idea is, what if that p-value was between 0 and 1? Let's say if it was like n to the 0.1 or n to the 0.0001. What's happening to this denominator if that p-value is a decimal value, like 0.0001? The denominator is basically getting smaller,
So the whole value is
getting larger. So if something is larger than the diverging series, then we know this series must also diverge.
okay.
They kind of forcing us into the comparison test too.
But then, like, what does that zero have to do with the whole thing? Like, if it's zero less than or equal.
That's just to ensure that it doesn't end up being like a -2. If it's -2, then this will be up top, and then the whole relationship is not gonna stand anymore. Yeah, that p-value needs to be restricted so that they can say that, so we can say that this is for sure gonna always produce a larger fractional value than this. That's why they gave that restriction. Okay, hopefully you guys have started number 6. But we can come to a stopping point, and then if you guys are finished, then great. If not, hopefully it's not more than 5 to 10 minutes to finish it. And then tomorrow I'll check pages 1 through 6, and that will begin your points total towards your first test grade, first AP test grade. Okay, all right, go get your phones. Okay.
Sure. Oh, I've been in class.
That's fine. Tomorrow I'm gonna check page 1 through 6. Okay, yeah, all right. Share today. Yeah.
Yeah.
Oh.